So starting at the top here, this one's actually pretty easy. It says circle Q has a radius of r. Okay. In units, the measure of AQB is x degrees as shown. Create an expression using r and x that can be used to find the length of arc AB in units. Okay, one thing that we need to remember is circumference of a circle is pi times diameter. Then to find the length of this, we need to figure out the fraction of the circle, and we do that by doing x over 360, whatever that degrees is, and then you can multiply it by circumference, pi times diameter. It says it wants the expression to have r radius, which would be 2 times radius would equal diameter. So our expression will actually look like this, x over 360 times 2 pi r. And that's what you'd put in the box. The answer key simplified it even further and had x over 180 pi r, but it also said that any equivalent expression is correct. So if you wanted to leave it like that, that is fine. B, it says, then create an expression that could be used to find the length of arc AB in units of circle Q were dilated by a scale factor of 3.7. When you dilate it, you're multiplying the radius by 3.7, the dimension. So we can just multiply 3.7 by the entire equation. So 3.7 times x over 360 times 2 pi r. You could simplify it if you want, but I don't know, no need. And down here, the trunk of a palm tree has cylindrical tubes that carry water. Each tube is 0.003 meters wide, so that's the diameter of the little tube. One of the tubes in a palm tree trunk is shown. Using the diagram as a model, approximately how many tubes could fit in a palm tree trunk with a diameter of 0.5 meters? Okay, so you're finding the area of the base or area of the circle here. And then you're figuring out how many of these little areas can fit in the area of the larger one. So the equation we're going to use is area of the palm tree base over area of the tube base. And the area of a circle is pi r squared over, area of the other one, pi r squared. Okay, so the palm tree, it says that the diameter is 0.5, so the radius would be 0.25. Square that times pi over pi times 0.003 divided by 2. 0.003 is 0.00015 squared. Then you would divide this out and you get this number. This says approximately how many tubes, so we're just going to round it to the nearest whole number, and the answer key has this. Somebody asked if you could also put the commas in there. You could, and it would still be counted correct. Normally on standardized testing, you don't put commas, only decimals, but. And for B, it says the tubes in the palm tree, so it's talking about these little tubes, are between 20 and 21 meters long. What is the approximate volume in cubic meters of one tube? The volume of a cylinder is pi r squared times the height. So volume equals pi times the radius, which was 0.00015 squared, and the height being 20 meters. Solve this, and the volume is 0.0000141. Moving down. Okay, polygon ABCDE is shown on the coordinate grid. It wants to know what is the perimeter to the nearest hundredth of a unit of the polygon. Okay, well, these lines right here, we can just count the units. 1, 2, 3, 4 units here. 1, 2, 3, 4 units here. Then to find the length of the diagonals, we would use Pythagorean theorem. So 2 and 3. So to find BC, 2 squared plus 3 squared equals C squared. The reason why I put square root of 13 right here is because these dimensions here is 2 by 3 as well. So solving it would be no point because I just solved that same problem. So CD is square root of 13. Then I need to find the length of AE. That's 1 by 5. So AE, 1 squared plus 5 squared equals C squared. I get 26. Square root of 26 is this length here. So to find the perimeter, I just add up all the sides. 4 plus square root of 13 plus square root of 13 plus 4 plus square root of 26. When you're studying on your own, I would make sure that you can get the correct answers in your calculator, whichever calculator you're going to use for testing. So square root of 13 times 2 plus 8, I get this number, plus square root of 26. So here I'm going to do square root of 26 plus 15 point. I didn't round because I didn't want anything to be off at all. And I get this number, 20.31012, and so on. It says to round to the nearest hundredth. So that would be 20.31. Next problem. This one here, it says, we're only doing 2 more problems, by the way. We're not even going to do this one down here. We're just going to do these 2 problems and we're done. So if you're starting to get tired, just hang in there. It says, one diagonal of a square EFGH is shown on the coordinate grid. Complete the sentence to describe square EFGH for each box. Fill in the bubble before the coordinate or phrase that is correct. So this is a diagonal of a square. So if you were to picture this square, it would look something like this. And this would be F over here and EFGH. Because when they name a polygon, it does go in order. So EFGH. Okay, the location of point F could be, so I just sketched it out, I just eyeballed it, and looking at the answer choices, -3, 4, that would not be where F is. -1, 6, that's about where I drew it, so that's probably the answer. And then 1, -8, nope. So the answer is -1, 6. If you wanted to be more precise, the other way to do it would be to look at the slope of that diagonal. So the slope of this diagonal is up 1 over 2. The diagonals of a square are perpendicular. So if you were drawing the other diagonal, you could go up 2 over 1 and use that negative reciprocal slope, up 2 over 1. And then you could draw this diagonal here. And F is at -1, 6. So these diagonals are perpendicular. And the last one, because diagonals of a square are congruent and they are perpendicular. They do not have the same slope. Their slopes are negative reciprocals. They actually do bisect each other, but that's not what we're using to find F. So. And the last one we're doing today, Ruben carries out a construction using triangle ABC. Click the play button to see a part of his construction. So I took this screenshot after they did the construction. So what they show is the compass making this mark, and then they show the compass from here making this mark. And then there would be one more step to this construction. It would be to go from here and make this mark. And what they would do is draw a line here, and they're bisecting angle B. So Ruben constructs a segment perpendicular to AC? No. Constructs a bisector of segment AC? Not necessarily. Constructs an angle congruent to angle B? No. constructs the bisector of angle B. That is correct. So the answer is D. And that's it for today.